me do this. Stream starts in 5 minutos. Okay. Hello and welcome to the stream. Let me do this number real quick. Streaming now. Oh my god. Now about material systems in game engines. All right. So hello, welcome to Math and Programming. It's been much more about programming recently than it's been about math. Hope that doesn't bother anybody. Maybe we'll get some more math topics in the future. That might be nice. But today we're going to stream about material systems. Hopefully it will be somewhat less scatterbrained than it was last week. I don't know. wasn't the best day for me. So, what's a material system? Let's start with that. What's the best example I can give here? Let's take a look at my renderer here. Got my renderer, and renderer has a draw model method right here. Draw model, and the maybe not the draw. Okay, maybe draw model. Well, no. Let's take a look at. I'm already getting into scatterbrain territory. It's not looking good. So draw model has. Sorry, a model consists currently in this engine. Consists of a number of meshes. There are some number of meshes, and then it's really simple. It just loops over all the meshes, and then draws the indexed buffer for each of the meshes. If you don't know what an indexed mesh is, I have a nice video about it on my YouTube channel. We'll explain what an indexed mesh is. What is my YouTube channel? It's my channel. Come on. Videos. Wait, let's do playlists. And math for game developers, and where is it? Which one? Fragment shaders? Yeah. So I don't know why this is called fragment. This is a bad name. Should be just rendering, I guess. Rendering. We cover a lot more things than fragment shaders in this. There we go. So index triangle meshes. Here's a video that explains them, if you don't know what they are. So, where were we? The model consists of a collection of indexed meshes, and so when you go to draw the model, it just runs through them all, rendering them all. And so you can see here, the draw index method, it takes an index buffer handle, a vertex buffer handle, an index buffer handle, some parameters I'm not going to get into now. And then it wants to know what is the texture for the diffuse and what is the texture for the light map. Okay. So let's look at the shader to make some sense of this. This is the fragment shader that's eventually going to draw the color for whatever fragments being displayed on the indexed mesh. And it assumes that there's a light map and a diffuse map, right? So this is because, and you know, this shader could have any number of maps. Right now I just have a light map and a diffuse, but it can have what? It can have specular, it can have normal maps, it can have any number of parameters that control the, you know, what are the standard like roughness parameters or whatever, what do they call it? Like this, I'm sorry, I'm terrible with words, so the exact words escape me, but there can be a lot of parameters that go into this shader that specify the, that you can control the properties of the result, right? But here in the draw indexed function, I'm just passing like diffuse and light map, even though not necessarily every shader is going to have a diffuse and a light map. Okay, so that's the problem that we're trying to solve here. That's what a material system can do for us. So let's see here. Let's go back to the shader. Every shader is going to have as its input a series of textures and a series of parameters. And so it's a material system's job to group all of that data together into one material. And so instead of sending the textures directly into this draw indexed function, you're just going to send one material. Okay, you're going to send one material, and that material has the information of what shader am I going to draw, what parameters do I have to set for that shader, and what textures do I need. It's going to have all that information within it. And all you have to do is specify the material and say, draw this indexed mesh with this material. The material has the shader, the parameters, and the textures all grouped together inside there. So that's what we're going to try and do today. We're going to fix this problem where the draw indexed mesh for some reason has to know about the light map, which is a bad design that I put in there for just like a temporary sake. We're going to fix that today. So let's go to some other engines and see what some other material systems look like for example. So I know one that we can find is source engine materials. I used source engine a lot in the past to do things I used to do. So I know what this format looks like. So a material in this engine is a .vmt. And so let's see. Shingle Beach. Oh, cool. Okay. So this is a good example of one. In this case, the top line here specifies the shader. Light mapped generic means that it's like it's a surface that you build in the level editor, Worldcraft, or they call it Hammer these days. And like it's a brush that you place in the level as opposed to like a dynamic entity. And all of those brushes get light maps on them. So light mapped generic is the shader that it's going to use, and then you specify the texture, and then you specify surface materials. And actually, I think in this engine, you can have non-rendering. Like I think this surface prop is not used in the rendering subsystem, but it's used in the physics subsystem, so that when you shoot it, like the dust spray that comes off of it is a gravel-looking dust spray, or a dirt-looking dust spray, or a grass-looking dust spray, or whatever. So you can have a bunch of different systems using this one material file. It might not be just a rendering thing, which is fine, I think. Okay. Let's see if Unreal. I've never seen any material systems for any other engines, honestly. So this might be an adventure for me. Unreal Engine materials. What do they look like? How do they work? They're probably physically based, yeah? How do I create one? Okay, so this is gonna probably, that was a text file. This is probably gonna send us into, like, there's probably an editor for it. Material editor, there's a material editor, there we go. Never having used, okay, so this is a very different way of specifying your materials. Unreal being like a very general purpose engine, and built not only for programmers, but artists and designers and all sorts of people. They have a more like general and visual way of specifying materials, it looks like. Actually, this looks more like a shader editor. So, Rocket of Awesomeness, huh? Yeah, so it looks like here you're creating the entire shader, not just the material level of it. So maybe they have a slightly different thing that they mean when they say material. Let's look at physically based materials here, because I'm just interested in that. Yeah, so this is the stuff I was trying to look for before. Base color is like the diffuse. These are all parameters that can go into your shader. So here they have this visual scripting language that lets you put together all of the, so you do a texture sample, so you specify what texture you want to sample, and then you add the result of that to whatever, I guess this is the alpha channel of this texture, multiplied by this color. So you add those two things together, and then you, oh, so this is what I want. This is what I want right here. So these are the inputs of a material. You have the base color. You have, these are the physically based rendering parameters. It can be emissive, meaning it emits light. You know, it might cast light on things around it, and then you have a bunch of other parameters that you can specify as part of the material. I think that's enough here. Let's go on to Unity materials. See what they have. Oh, okay. So it's pretty similar. So you have a material, you say, hey, I want it to have this albedo and diffuse are basically the same thing. This amount of metallicness, this amount of smoothness. Does it have a normal map? Does it have a height map? Does it have an occlusion map? You specify all these things in your shader. In this case, you don't have to do it in text file like you do in Source Engine. Instead, you do it in this inspector view. And then you save it, and then when it comes to time to render a model, you can tell it, hey, use that material. Okay. And it looks like you have a little bit of granularity as far as like what the what the material does, what the material can do. My nose itches. Sorry. Okay, so that's hopefully that gives us some idea of what a material is, what it does, what it's for, why we want it, why I'm about to go start coding it. 2 hours, man. We only got 2 hours on this stream. Oh, an hour and a half now because I was rambling about what a material is. So that's not a lot of time. We might not get done with it today. So let's just try and get as far as we can here. First thing I'm going to do, let's see here. T material. So I'm going to create a file format for a material file in general, right? Like this is, the materials are going to be stored on the disk in some way, and then there has to be some kind of file format. I hope this is apparent. So we have to decide what goes into this format. And, weird. So, hold on. Now I have a choice to make. Unity materials. And Source Engine materials. Well, the Source Engine way of doing it is just a text file. And, you can kind of put anything in it. Whereas if I do this, light map texture, then this light map texture parameter is going to take up space, even if there's no light map for that particular shader. I suppose shader is the first thing I should put there. So, I wonder if it's a better choice to do this, parameters, and then just have an array of strings. And that way each, this is kind of a typeless way of doing, this should be like T material parameter. So that's a format. Let's copy this. Okay. So we're kind of like flattening our parameters instead of hard coding them all here. Light map, texture, and then diffuse texture. Instead of that, we're gonna have material parameter, and then the parameter name, and then the parameter value. And so we're just gonna have like an array of T material parameters here. And that seems, I don't know, that seems more reasonable than, there's less type safety this way. So for example, if it's an integer parameter, then you're still storing it as a string. So that may not be the best. I could try and work around that. I could say type, and then there's some kind of material parameter type here, and then I have like a variant where either the string is the valid value, or the int is the valid value, or something like that. And which value is valid depends on what is the value of the type. But I don't think I want to do that. I think I'm okay with leaving them as strings and letting them be parsed, at runtime there. Until I'm convinced that there's that that there's like a definite performance cost to doing it this way. I think I just want to keep it simple and just be value string. So, by the way, rule of this channel is that I'm very happy to answer your questions. If you have any questions, feel free to ask them. Look below in the channel description. It says right there, asking questions, please do. So I try to explain everything as I go along, but like sometimes I miss things, or sometimes I don't explain things well. So all right. So you have this array of material parameters. I want to say like, if we start at the beginning, then what I need to do is add this to my Igor. Igor being my little helper that compiles things for me. Igor. So Igor has a bunch of different formats that he knows about, and hey Sean, and he will compile my things. And so like, what does okay, this is a big bunch of questions. I'm making material system, but I don't want to make a material editor. That sounds like a lot of work. Maybe I can just make but I at the same time like want my materials to be in at least this binary format so they can load a little. Honestly, a text format would not be so bad for materials. I mean, that's the way Source Engine does it. Maybe I should just have a text format for materials, but if I do that, then I'll have one thing in my engine that has a text format and everything else that has a binary format, and that would make me sad. That would make me sad. But then that means that I gotta have it be like I don't want to make an editor, but I can still make like a really simple material format, like kind of like what Source has. But then it gets translated into the binary format, and I'd probably be okay with that. Yeah, let's make that. I could probably do that in just that part of it in 2 hours. It's not very exciting, is it? But no, let's skip that part. Let's skip that part. Let's do this. Let's do this. I'm gonna have Igor spit. This is what I'm gonna do because I want to get like actually something marking tonight and like showing up on the screen tonight, instead of like just what we were doing before, which is like 3 hours of coding and then the result is that like a line of text shows up on the screen. Me? No. I did, Source Engine isn't the paragon of load times. That's true. The game that I worked on before I went back to school was this game, and I did it in Source Engine. In fact, this is like a Source Filmmaker. We did the trailer in Source Filmmaker because, I mean, Source Filmmaker is great, and we had it available to us. So yeah, this was a Source Engine thing. So I'm pretty familiar with Source Engine, and I tend to borrow a lot of ideas from Source Engines because I used it for so long. I'm sure if I had used Unreal for so long, I would have done that. But I don't know. I don't think Source Engine's that bad with load times, especially for like, it's like how old is that engine? Like 13, 14-year-old engine now? I don't know. Anyway. Okay. So, right. So I'm just gonna make Igor like spit out a really simple material that I can use as an example, or maybe just like a few really simple materials, and that would be, I feel like, probably better than like doing a lot of work to get like a text to binary translation going there. Okay, So let's try that. All right. I'm gonna start with making a new file. Team material. All right. And do I have to add it to CMake? No, but I do have to rerun CMake. Oh, wow. Git push apparently hangs my computer now? Weird. Wow, that's really weird. I ran this git push command this morning and it's still sitting here. Trying to push stuff. Ping Google? I don't know, I'm streaming so my internet must work. I don't know why git push wouldn't work. Oh, there it goes. It's just the internet was sneezing or something. Okay, anyway. So I have to run CMake because I added something to the project file. All right, here we go. Now, let's include Igor.h. Igor.h. And then we're gonna add this compile t material. Okay. And I have this list of all assets. And I'm going to add a material. Name. So light map. And material. Name. What's a name for material that's not light mapped, but it's like dynamic light or something like that? I don't know. I could probably think of a better name for that, but name dynamic light. Okay. And so we define this. We're just doing a bunch of boring stuff. And like that. Okay. So far so good. Should build. Or wait. Oh no. I thought I stashed all the stuff that I was doing before the stream so that it wouldn't interfere with the stream, but I guess maybe I missed some things. If so, I apologize, except 206. There's no, oh, there we go. Yeah, that should be, that's not format. Static, geometry. You know what, I probably just have to rerun the, make Igor run. No, wait. Make. Just make. There we go. I just have to rerun the thing to regenerate the thing. Okay. There we go. Now we have a different error. Unused parameter config. Okay, that's fine. So we have to teach this thing about materials. Tinker format. Material. Where's Tinker format? File formats. Tinker format. Material. Here we go. Get asset table type. Oh, it's been a while since I modified this code, so. File formats.cpp. Do I need to add this guy here? I think I do. Oh, wait. If you change this, also change G4. Oh, good. Okay, good thing I left myself that note. T material and materials. So this is the file name that a material will have, and this is the directory that materials go in. Material and get asset table type. So get asset table type material. George or Vino, either way, I don't mind. What advantages do you see in using a format over just doing it in code? How do you find debugging materials not using code, or is it really a problem? It's up to you. So the trade-off here is a pretty classic trade-off, like when you do things in hard code in code, when you hard code things, you're paying a price, right? The price you're paying is flexibility. If you were the only programmer or even the only user of a system, it can be worth it. Like if you want to go change, you know what you want. If you want to go change it, you can just go change it in the file. It's not a big deal. Okay, so that's the example. If you're not the only user, other people are going to be user. They want to change it without having to change the source code. Multiple people using it or multiple people programming it, then hard coding thing. That's where hard coding is bad. So the advantage of having a format is that it makes it really easy to change. So as an indie programmer, an indie game designer, really. Which technically I haven't been for a while, but say I'm making an indie game, I have to be able to change my level of abstraction. Okay, at one point I'm programming and I'm doing like low-level work, and then that's in support of some design work. So that at some point I have to switch over and say, okay, I'm not programming anymore. I'm done programming for now. I'm doing design work. I'm not looking at code anymore, and now I'm manipulating things that I did previously. So you leave code behind, and then it's really nice in that case to have just like simple editors and file formats, and things are not hard coded in your code, right? So you can leave the lower level abstraction, enter the higher level abstraction, not have to do any code there. How do you find debugging materials not using code? Debugging data-driven stuff is always harder, but the way I approach it is, if that's what you have to do, then that's what you have to do. I don't know if there's, I don't feel like I'm really giving a very deep answer to this question. So I don't know. Maybe somebody else in the channel has some thoughts on it. If you need data-driven materials, then you need them, and you just if you don't need them, then you shouldn't put up with the extra friction, because you're right, like debugging hard-coded stuff, it's actually easier. So, okay, well, let's move on. You can ask me more questions about that if you want. I don't want to drill that one into the ground. Okay, so compile material. So at some point we're gonna have if config get key equals, and we're gonna, like I said before, we're gonna super hard code this light mapped. So we have two materials here, and I'm just gonna hard code what the results of the materials should be. Oh wait, should be to get value name. So I'm just gonna manually write the light mapped shader at this point. Okay, why do you use formats then? Do you like them? Why do I use file formats? Hold on, that's like a really broad question. I'm not sure I understand it. Why do I use file formats to store my data? You kind of, what else would you do? I'm not sure if I understand what you mean by that. Do you mean like, you're saying why do I write it to code instead of, I'm sorry, why do I write it to a file instead of loading it all from source code? I think that's your question. Or material formats in particular is what you mean? Building off the previous question. Okay, hold on, member access to, oh, I have to do this. Okay, let me show you something I did in a previous project And maybe that will... Okay, I'll get back to this. So, go to my GitHub. All right. Actually, this was like 3 games ago. I made this game, Digitanks. Source code for it is on GitHub. I look at this engine these days and I just think, gross. But there it is. So, Digitanks, source, and then at some point, where was it? No. Oh wait, did I do the disgusting thing that I think I did? No, I didn't. Hold on, I'm looking for something in particular. Somewhere around here I have like a source code file that contains all of the particle systems for the entire game. Here we go. So, so this is I think what you mean. At the very beginning of the game, I initialize the particle systems library, and then I literally like in code, I say, okay, this. So I'll create a particle system called intro explosion. This isn't for the game proper. It's for like the little introduction of the game that happens when you load up the game, which is like in a separate game. It's a separate instance of the game engine, so everything is prefaced with intro. But anyway, create a new particle system in code, and then I have it here, and then I add 2 like children to it, and then each child gets like some properties, okay, and so I set the material, I set the lifetime, I set all these parameters, and then I do it. Yeah, I add another one, explosion fragments, and then so I do all this in code. Like I could have done it. I could so this is particle systems, and I could have made a an editor for it, but it would have just taken more time, and I'm the only person editing it. Like there are no other. I don't know. Like there are no other clients of this code, and in this case, it would have been nicer if I had like a visual particle editor, but the amount of extra work to make a visual particle editor is just too much, and I figured I'll just edit it in code and do like edit and continue, or even just restart the game, and that's less total time, and it's not as nice, obviously. Like you don't get. You either spend more time and frustration for the same result, or you don't get as good of a result if you do it this way. So it's just a trade-off. You have to just think about what you're getting there. I could do this with the material system. In fact, I'm about to do this effectively, but then later I'm gonna have to go back and replace it with the actual thing, because materials are something that you want to be able to edit like really easily. I think / hope that answers your question. Here they are. Just a huge file of all of the particle systems in the game. Don't take any hints from this. This is not good, but it served me good enough for making that game, so I don't know. What can you do? So we're gonna return build result fail for the time being. Let's see. Let's do this, actually. Let's do this and this. So now, no member named material. Assets type. Okay, I have to add it here. Material. Up. So that means I have to add it here. Material. And here. Material. Asking because you're relearning programming and dealing with scripting languages and other formats along with the code sometimes gets overwhelming with what to learn. Yeah. Sure. I think, like, I have this theory that a person has, like, a rate at which they can learn things. Content compiling failed. No, that's fine. And past that rate, you just don't absorb things, right? Things will just fall in one ear and go out the other. And you need to, like, if you're learning too many things at once, like, so what you need to do is, like, learn some things and then just, it's a function of time. Time needs to pass while that gels in your mind, and then you learn the next thing, right? So, you know, come back to it later after the one thing has already gelled. For example, with learning, it's not the case that you can learn 10 things in one day and then know things the next 9 days. You really need to be learning one thing every day, just slowly over time. And the rate is different, slightly different for different people. But anyway, the point is, come back to it later. It'll make more sense. Okay. Let's now boot that up over here and see it at work. I always like to get into the debugger as fast as possible. Oh wait, we need to rerun CMake for this guy to generate. Okay, so now we have T material. And I'm gonna set that breakpoint right there. Compile it, run it. Seriously? Ugh, last time this happened. Oh, this is the worst. Oh, this is the worst. This is like a compiler error that sometimes comes and goes and like, ah, crap. This is the last thing I want to do. Like there's something not compiled properly, and like it gives me this assert when it shouldn't be. Like, this code is correct. I'm sure of it. Ugh, this is frustrating. What do I do? How do you tell clean? Will that actually cause it to compile it correctly this time? I don't know. Nope. Damn it. Okay, this is the worst. I don't actually want to spend any time with this. So yeah, I ran into this bug yesterday, and like some, like, you change a header file and then something gets updated, but like it doesn't, some file that this thing depends on isn't being recompiled, and so it's hitting this assert and it shouldn't be. And I don't know, this, I guess it might be something I'm doing, but like double and triple checked that it's not my fault, because like it works fine over here. Let's do this. We'll just use the command line debugger for now. That's what we'll do. Okay, fine. Make Igor run. See, works. See, it's not my fault. Works fine in the command line version. I don't know what the hell is going on with with Xcode. What? Yeah, I don't want to deal with it now though, so we'll just use a command line debugger, which isn't the greatest, but I apologize. I still haven't figured that problem out, and I don't want to spend time on it right now. Okay, so fine. So let's get the actual command line that it's running. Here it is. Copy that, paste it. Add LLDB, which is going to be our debugger to the beginning. All right. And then we'll set a breakpoint at compile T material. Run it. What? You guys saw that, right? That's not just me. It worked fine a moment ago. What is it when I like run it not in the debugger? It works fine? Oh no, now it's crashing. So make you go run. When I run it as part of the build process, it runs fine. But when I run it not as part of the build process, it doesn't run fine. Oh wait. Maybe the database is corrupt. I'm sorry about this, folks. Database looks fine. Nothing wonky about the database. Like, nothing has changed about the database. I'm so confused. This crashes. This doesn't. Alright. Alright, well this works. So I'm just gonna debug with printfs. Oh my god. I gotta figure out off stream what is going on there. Get value. So let's see the names that we're getting through here. I have to say .cstir. Name and name. What? Get. Oh, this should say get entry. No. Find entry. Find entry. No, find value. Find value. All right, so light mapped and dynamic light are the names we're getting here. Okay, good. So for light mapped, we're going to create, let's include the file format. I actually like watching me use the command line debugger. I saw you use it a few months ago and was one of the few on stream who use it. Trying not to depend on Windows Visual Studio, so watching how others debug is interesting. I really wouldn't recommend using the command line debugger if you can. It can work. It's workable, but I mean, it's not terrible. It's not the worst I've ever used. Yeah, and it helps me sometimes in places that the Xcode debugger is not so great at. Windows actually has a command line debugger too, but I've never gotten around to learning it. So, but honestly, I use Visual Studio as my primary debugger. I feel like debugging is a thing that really should be done in a GUI. It's better. It's easier to do in a GUI than it is to do outside. I don't know, whatever floats your boats, honestly. So file formats dot t material dot h. So we're including the header file for the file format that we're going to write. File formats t material. So let's create an instance. File formats t material instance create. And make sure that that gets destroyed. Instance free. McGrath. Oh, that's McGrath. I didn't realize McGrath ever was writing a debugger for Linux. That's interesting. He doesn't always pay attention to the whole stream, though. Forgive me for a slight off-topic question. I was curious. What's for my dislike plugins tweet? Okay, I'll talk about that. So every time you add a plugin to something, you create more work for yourself, right? Like obviously you get value from whatever the thing is that you added. But you also create more work for yourself. For one, you have to actually go add it. So you have to spend time to going and adding this plugin. Two, let's say it's a browser plugin. The browser updates, and then like the plugin doesn't, like the plugin doesn't, the versions don't match or something, and then you have to like have a new version of the plugin to match the new version of the browser or whatever, or maybe just breaks somehow. So your plugin breaks, and the plugin's not tested by the people, like the people who make the browser used by a ton of people. So it gets tested a lot. Like there's this relationship between the number of people who use something and the amount of love and testing and like usability, how good its usability is, and this sort of thing. The browser, lots of people use it, lots of testing, really good usability in general. The plugin, probably very few people use it. Like not well tested relatively, right? So you have all these problems. Then you get a new computer, and then you have to go and reinstall your plugins, or a new browser, and then you have to find new plugins for the different browser and like get all of them installed. It's a pain. Like the more plugins you get, the more you're just you're like juggling plugins instead of, and at some point, like that cost starts building up, and I'm like, I don't even care. Do I really want the value that the plugin gives me that much? Like, it's a very few plugins these days that I actually say, yes, I do care about that value. Adblock's one of them. Like, that's a no-brainer. Adblock's used by a lot of people, so they tend to be like better, easier to install, and easier to find, and well tested and this sort of thing. And the value is tremendous. I don't have to look at advertisements anymore. That's really valuable to me. Other stuff, like the older I get, the fewer plugins I have, and at some point I have like one plugin now. And then here's another point to be made about plugins. If the value were so high that you actually do need that thing, probably the browser vendor or the whatever program that the plugin is for is going to integrate that plugin, and we've seen that a lot in the history of browsers. Used to be that everybody had pop-up blockers, and now where is it? The pop-up blockers are just like they're just there. I don't even know how. See, I have the ad block. Where are the pop-up blockers? Yeah, like this sort of thing, like plugins to control your privacy and this sort of thing. Like browser vendors have slowly figured out, if everybody is integrating is downloading this one plugin, then maybe we should just make that the default, right? And give that value to everybody. And so you see, oh wow, I'm gonna check that box. And so you see like things like pop-up blockers and password saving, you know, autofill, tabs, like all this stuff used to be plugins. Now it just comes with every browser, you know? So like instead of dealing with these plugins myself, if I really need them, I can just wait and I don't have to deal with that hassle in the browser or whatever program it is, we'll get it eventually. So, so that's why I decided I dislike plugins. I acknowledge that there are cases when people need specific plugins and they give more value to them than, so it's worth the, but in the general case, like, I don't think people usually need plugins as much as they think they do. Thanks for asking that question. It was really fun to answer. Oh, follow up. Would you rather the browser or application have that functionality, or would you rather just not use plugins at all? Yeah, I think I answered that in the second part of that. So okay, where were we? Material format equals instance get format. So here we're going to get the actual data and we're going to start writing to it. Material format dot set shader. And so we have a shader, we have a shader, we have a shader. Shader's gonna be, wait. Oh, you know what? I can't do it this way. So my shader is actually like a program state object. Appreciate the answers. My pleasure. See you later. The shader is actually like a program. I'm sorry, a pipeline state object, which we covered in a previous video. Which doesn't have a name, I don't think. Hold on, so let me come over here. So in the renderer, I create a pipeline state object, pipeline state, and I load that into my resources, and this is what I need to refer to right here. Like this pipeline state object is the one that the material should render with. Oh, but this is see, I didn't even think about this. This is a problem because this pipeline state object doesn't actually have a name or any way that I can refer to it. Where'd it go? Where'd it go? In my renderer. So like, not this one because this is the debug one. What is this? Is also debug. Here, light mapped PSO. Okay. So this is the light mapped pipeline state object. So it's a pipeline state object that draws light mapped things. Okay. So you can see it uses the fragment shader with the light mapped, you know, the model fragment shader with the light mapped option turned on. And then it will fill out all of these parameters. I guess I just need to give this thing a name. Bob. Bob is a name that I could give it. Do I really need to be giving this thing a name though? So like the other way of doing this is that I have this material that I'm about to, right? And then I set So okay. So when I say material, maybe what I really mean is all of the description of a pipeline state plus the texture and parameters that should go into it. So So whereas here I am, I'm creating like a fixed pipeline state, and then using it later. Maybe what I need to do is, so let's see. So what are the, here, maybe this will make it more clear. All of this stuff needs to go here in my material. So for example, vertex shader, that's a string. Fragment shader, that's a string. This stuff is tricky because I'm not sure that needs to go into the... no, that does need to go, because then that's what all these things are. All of the material parameters. So it would say uniform buffer, like all of the different textures that it needs here go here. Oh man. So I thought I had a pretty good design for this thing when I started for the evening, but that's because I've never written an engine with pipeline state objects before. So it turns out I don't have as clear of an idea as I thought I did. There's a lot of state in the pipeline state object that I'm not sure you want to end up in the material. For example, this stuff. Or do you? I mean, I could just like load the entire pipeline state object. I'll also call it a PSO, which I'm just gonna call it a PSO from now on. I could load the entire PSO into the material. Then when you load the material, all it does is creates the PSO from that data, creates all of this stuff, does all these lookups right here, and then it stores that PSO and uses it whenever you want to draw with that material. And if I'm gonna do that, I mean, I could do it that way. That is way more work than I'm gonna get done tonight. Damn it. I thought this would be like a small thing that I could bite off and it would only take like a little bit of time, and then by the end of the stream we'd have something showing, but it's not gonna happen tonight. Especially because now I have to do a bunch of thinking about like the design of the material and how much of the PSO information it should include. And then the other alternative is just to like refer to an existing PSO. But I don't like that because then you can't create, like you want to be able to. So like if you have a fixed list of PSOs in the engine and you're just referring to one of those, I mean, it's not unreasonable. You can't like, but you can add shaders. So I can add shaders without modifying code. Here's one, right? Like I just add them to this file. Here's another one. I can even like, yeah, so this is, so yeah, this is the model shader. So if I want to add a shader to my engine, I can write the actual shader, add this block in here, give it a name, and then these definitions map to, where is it? Model.fs map to this debug light mapped, right? Map to actual pound defined in the shader file. So I load those in here, and then, you know, the asset compiling system knows about it. So that's it. That's all I need to do to add a shader. Currently, if I want to add a PSO, I have to do it in code. It's not so bad. Like we were just talking about, if I hard code things, it does make it easier and faster. And then the question is, like, how often am I going to be adding PSOs? Materials, quite often, probably. Quite often. PSOs, probably not all that often. You have like a handful of PSO. Really, you want to have as few PSOs as possible, honestly, in your game. And you want to do as much like rendering with as little, with just a few PSOs. Not a rendering expert here, so I don't know that for sure. But I believe I'm just repeating the experience that I've heard actual rendering experts say, like that you want to just have a few PSOs and not managing a lot of PSOs. So maybe the ability to create new, like if you map materials exactly to PSOs, like the way I was saying, then that's possibly a bad thing, because, you know, then you have this. If it's really easy to create PSOs because you do it every time you make a material, then people will use PSOs. People will do it a lot. Like I will end up doing it a lot. And if we only want a few PSOs, that's bad, right? Like PSO is a pipeline state object. For those just joining us, I'm making a material system for this engine. Which is a way of abstracting, like a material has a series of textures, like diffuse texture, normal texture, and a bunch of parameters. And all of that is grouped together, and then when you go to render a mesh, you render it with that material instead of sending all of the individual textures. So it's a layer of abstraction in your engine that lets you easily create specify all these parameters for how things will be rendered. And the pipeline state object is a function of the renderer. It's a big blob of data that specifies how you're going to render something. And this is an example. So this is the description of a PSO. What cull mode am I using? I'm going to cull the back faces of triangles. So I'm not going to show the backs of triangles. I'm going to write to the depth buffer and test the depth buffer. This is... I'll get to that, but it's all of the default attributes for models. These are all of the uniforms that I'm going to have with this shader. You can see that, I have a bunch of uniforms here, and then I look up which shaders I'm going to use, and all of that information gets rolled into the actual PSO. And let's set up model attributes. So this is the vertex layout of the mesh. Each mesh is going to have each vertex is going to have a position, a texture coordinate, and a normal. And this specifies the layout. So the first 3 floating point values will be the position. The next 2 will be the texture. The next 3 will be the normal, and so on. And as I turn features on in the engine, I can add things to that. So all of that data, the vertex layout, the rasterization data, the uniforms, the fragments, the shaders that will be used, they're all wrapped up into a pipeline state object that specifies all of that. I have a render request buffer. Then the renderer sorts the materials with similar pipeline state and renders them in batches. Yes, exactly. You can do that for sure. You can just send materials to the renderer in whatever order, and then the renderer will sort them. You got to be careful with that sorting routine, but yeah, you can just reorganize these two use the same pipeline state, put them together. Another approach is you can sort it before you send it to the renderer. Like you have a bunch of things in your game and you know you want to render them all, so you put a bunch like these in this bucket and then these in this bucket and these in this bucket. And then you send this bucket and then you send that bucket and you send that bucket, right? So and all, you know, this bucket has this PSO, that bucket has that PSO. So anyway, the question is whether a material should be tied closely to a PSO so that if I make a new material, then I get a new PSO. I think the answer is no, actually, because say I want to do this. So here's my material. A material is actually a PSO, you know, light map, plus a specific texture, diffuse texture, wall, you know, brick wall, and a light map texture, light map 2. You know, and that'll be automatically generated, of course, but a normal texture, normal brick wall, normal, or what have you. So this part can be shared between many materials, but all these are going to want to differ from material to material, right? Because, you know, if I were to save this guy out, this would be brick wall dot material. So I think the answer is you don't want to create a new PSO every time you create a new material. So we're not going to do that, but that means that we definitely have to create, like give all of these pipeline state objects names so that they can be looked up here by the material. Otherwise there's no way to like find the material that you put right in here, and then we're going to have a bad day. So that's not so bad. That's not so bad. So let's do that. All right, let's close this guy. So instead of saying shader here, we're going to say PSO. So we're going to specify the PSO that we want to use. Then over here, we're going to say set PSO, and we're going to say the light mapped. So that should compile. Oh, there was an error. What was the error? Oh, the error is because, okay. We're just going to do the same thing down here. Wait. No, we're not. Dynamic light. Okay. So this is actually going to do absolutely nothing because we haven't actually written out the file, which is fine. Because I want to come over here and go to the resources, and now when we create a pipeline state object, we have to give it a name. Ugh, I don't like that. I don't like that because nothing else in our resources system has a name unless it is in this file. So everything in this file has a name, like this thing's name is entity/entity. This thing's name is black. This thing is black texture and white texture. This thing's name is starting point. Just give a name to everything in this file so you can refer to it later. This is not the best system, by the way. I have to go in and change this system because it should be like, should be different. But because you can't have a texture called black and a material also called black. So I need to do some extra name spacing here. I hope that makes sense. But anyway, maybe that's okay actually. Hold on, quick tangent. If I do find resource, no, see this will, no, so there's a type here. No, wait, no, I need lookup resource. So if I do lookup resource, yeah, then I just tell it, this is like gamer editor and then name. So maybe what I can do here is I can, you know, assets type, specify the type, and then you've effectively namespaced it by the type. And so material black is different from texture black. I'm gonna do that later. I'm not gonna do that right now. But that's what I have to do. That will solve a lot of problems actually, because then you can have two different types of assets that are the same name. But for now, let me see, where was I? So if I give like, okay, so normally if the thing's in this file, then it has a name. Otherwise it has no name, except for pipeline state objects, which will have a name even though they're not in that file. And that's, I don't know, that feels weird to me. That doesn't feel like the greatest. Because pipeline state objects you have to look up by name because you have to refer to them from like outside the program. From data. I'm not sure what else I could do there though. Give pipeline state objects a name, but nothing else a name, unless it's in the assets file. Okay, let's take a look inside assets. My assets class. Resource class. So here's my resource class. Yeah, see, like there's not even a field in here for name. If I want to look up something by its name, I go to this, like this file turns into a big database and it maps the names to these numbers right here. And then the numbers are what are used to store the actual thing because they're stored in a hash, or I don't know if they're stored in a hash yet, but that's my eventual goal. And so that number is used as the hash. So I would have to like add a name here, but only for PSOs. What does the PSO data structure look like is the next question. Pipeline state data. Yeah, so I could like add the name to the pipeline state data here. And then only pipeline state, but that's, so that like, if I add it here, like this is a specialized kind of resource, you know, this is all of the information for the PSO. And I could add the name here and that way like only PSOs are lookupable by name, but that sounds even worse. It sounds like I just need to support assigning names to things that are not in the assets.txt file. No, you know what? I think I just want to do it for pipeline state data and then have like a separate, so here's what I'm going to do. Because I don't like the idea of putting, you know, a string name here just for PSOs. That seems like a bad design. So instead, I'm going to put the name here. Okay. And then I'm going to have a function somewhere, a special function that's not even part of my resources class. I have no other similar functions, so this is kind of dangerous. But I think this is like the least bad solution. So like, for example, frame buffer description. What the hell is this thing? Oh, no, that's cool. Okay. So I return a pipeline state handle, and I say look up PSO by name. Okay, just like that. This is my special string class that I probably shouldn't have written. And I forget what the member t-string. So I gotta give it pipeline state data. So I put the name here, and then I have this special function that I can write that will look up the PSO handle that corresponds to the name that I give it. And this actually can be a stud string view. And that doesn't seem so bad. All right. So now I can create pipeline state, string view, give it a name, create pipeline state, string view, name, and now I just have to pipeline resource data this, name equals name. Okay, so now I can look up pipeline state objects. So that means that's probably not going to compile. Where is it? Yeah, so now I get to update all of these with names. Tone map. All right, this pipeline state is now called tone map. This one is now going to be called imgui. I have imgui. So imgui is the first PSO that I made in this engine. I probably shouldn't be using a special PSO just for imgui, but it was the first thing that I wrote. So it, eventually I'm going to go back and like rewrite it so that doesn't have its own thing. But yeah, because I could probably use like this one, the regular debug PSO that I'm going to use for all other debug drawing in the engine. I could probably just use that for imgui instead, and that should work fine. Light mapped. There we go. So now all PSOs have names, I'm pretty sure. No viable over... What? Why not? Oh, I probably need to do this. Dot assign. Something like that. Is that what you want? You okay with that? No? Maybe? Yeah. Oh, okay, good. Let's see. Oh, this one's also called tone map. Uh-oh. Then we're going to have two... Okay, this is Grotto tone map. And there we go. Now we compile. So now all of my PSOs have names. I'm not going to write this guy yet. Look up PSO, kind of a boring function there, so I'll write that later. Render. So going back to Igor. Good. So we have our light mapped PSO. We just named it. Everything's working fine. I didn't make this one yet. It doesn't exist. We'll still make the material for it. But, actually, let's just make things simpler for ourselves. There. Yeah. Doesn't even have to exist yet. We'll worry about that one later. All right. So now let's start adding parameters. Material format dot. I forget the, okay. So now we have to say tMaterial. File formats dot tMaterial. So I forget the syntax to add a thing to my parameters. So let's see. It's push parameters. Push parameters. So that will add something to the parameter list. And then, yeah, let's do this. Using namespace file formats. Now I can get rid of all these. Yeah, good. So I can just say tMaterial parameter. And what parameter do I even want to add? So I guess start with the diffuse, I guess. I don't even know what, Okay, this is weird. Yeah, I'm creating like a specific material, even though the material that I need to create if I'm actually going to render something should be, I just realized this, auto-generated by the level editor and stored in the level file. Yeah. So I'm not even doing the right thing here. This is pointless. Okay, so backing up and explaining that. Here's what I just realized. Currently the only thing in the game, let's run the game. Hopefully it does run and we don't hit that error that we hit before, which was a silly error. If we run the game, the only thing I actually have showing so far is, that's fine. Nothing to worry about. No cause for alarm. Here we go. Whoa. Here we go. Yeah, this little test level that I have going, that's it. So, it's gonna render all the light maps. So beautiful. Beautiful light maps. And then I hit Control G and I go into the actual level. And as you can see, there are no light maps, even though we just rendered them because I have no materials. So that's what we're working on. But that means that, like, so the editor is gonna, you know, compile the materials. Here are the materials compiled. And then, like, it's not, see, these aren't gonna be materials that you hand compile because the editor knows which light map goes to which materials. So what I'm gonna have to do is, you know, when I hit Control G, it's gonna have to on the fly compile those materials and then send them over to the level, to the finished binary of the level. So I just realized that we don't even need any of this. I'm brilliant. I'm so brilliant. It took me till now to realize that. What we really have to do is go into here in Igor, but in T-level instead. So in T-level, we generate the light maps here. I don't think we ever actually, so this compiles the light maps and it takes forever. I don't think we ever actually write them to the drive. But like at the end of this, I commented it out because it takes forever. It's not being used yet. But then at the end of this, we have all of these like light map images. So those guys need to go to the hard drive and then material files automatically generated for them. Those material files included in the level that this code generates, and then they'll be there and available. And so the whole question about like building a text editor, we want to avoid building a text editor that like has, you know, that displays materials. Sorry, a text editor, like, backing up. The whole issue that we had at the beginning of the stream of wanting to create a text format that's compiled to a binary format for materials is kind of moot because we can do the whole thing in the level compiling process now. So let's do that instead. All right. So the first thing to do is over here, definitely 20 minutes left in the stream. Definitely not getting this done tonight. I'm having fun, so I'll probably keep going past 8, but definitely not getting this done tonight. All right, so here's the level. Oof, this is something that I've already changed in the work that I stashed before. I have this static geometry. Like I have this is bad design that I'd like to talk about real quick because it's bad and I'm embarrassed about it. So in the first version of the level, I have the name of the file that has all the static geometry that I want to compile. It's right here. And that I feel like that's no good So what I did is I just got rid of that. And now I have an entity that's like the static geometry entity. And so you added, like, there's a list. The level is basically a list of entities. So you add an entity to the level that's like a static mesh entity whose job it is to just sit there and show the static mesh. I feel like that's much better design. So in any case, I don't think we have to change that for now, though, because we can go to the model format. Where's the model format? Model format is a series of meshes. This is where it's going to go. It's a series of meshes, each mesh having light map, vertex data, index data, number of verts, etc. All this is the vertex layout. Math. We're actually not doing that much math today, unfortunately. But if you have any math questions, I love answering math questions. I love talking about math. I'm happy to interrupt this, which I'm not getting done tonight anyway, to talk about math. This is kind of C++, but a pared down version that is mostly just C features. But I do have some stuff like this, which is a C++ feature. I don't use most of what C++ has to offer, for reasons that we can discuss if you're interested. Where was I? What about networking or cybersecurity? I know next to nothing about cybersecurity. And relatively little about networking, but I might be able to answer some questions if you're curious. But chances are good you know more about networking than I do. So this looks good, except I feel like what I need to do is, instead of light map here, because not all meshes will have light maps, so that's an obvious fault. What I need to do is make a new version of this. Get rid of light map and say material instead. Material instead. Yeah. Yep, and this will be version 1. So this will address a file that contains the material that we're going to write. And now this should break. Yeah, this does break. Because, for 2 reasons. For one, gross. I have a bug in my format library, which I need to fix. I won't dwell on that. But for 2, oh crap. Let me go apply the workaround right now. BTB format.cpp print. Here we go. And there we go. Workaround applied. It is a gross workaround. Okay, so that compiled. How did that compile? I guess I'm not actually creating any models. No, I do have a model compiling thing here. Oh, I just never actually used the light map parameter, which is good. So now anytime I need to write a model to the hard drive, I need to also include the material that I want to render the model with. This is not very general code because you can see that it assumes that any model that I want to write only has one vertex mesh associated with it. when the backing format has an array of meshes, each having their own material. So here I can only write one material. So it's probably not so bad though. I'm probably gonna have to improve that in the future, but I'm not gonna do it now. So for now, I need to expand my model, my compile, let's see, compile T-model and write T-model code so that, in addition to all this other stuff it takes, it knows what material to write. String view material. All right. So where does that go? Right here. And now we can say mesh format set material. That was easy, except bong errors. And so we need to come down here. What is this? T level? Yeah. So here's where I need to write the fucking material. I'll do that in a moment. Oh. No matching. Oh, that's just because the set material. Okay. File format. Let's do this. Compile this guy. Yeah. So file format T model. No, T mesh. String, yeah, so the string view that this guy uses is different from the standard string view, which is annoying, but not a big deal. I can just say, well, hold on. Set material. Yeah, I'll just do this. There. Actually, it doesn't even accept its own string view for some reason. All right, that's boring. So that's better. All right. So, yeah, totally not getting this done tonight. So my compile model function needs to know what material it's going to write. So let's see here. In my assets file, if I want to compile a model, where is it? Model? Do I have any models? I have exactly one model. And oof. It's like I go to do feature A, and then in order to do feature A, feature B relies on feature B needs to be considered in feature A, and then feature C needs to be considered in feature B, and so like I have this chain of things that I have to do in order to do feature A. That's what's happening here. In order to do materials, I need to update models so that models have proper materials. You know what I'm going to do for now is just, or how about this? To do material. So it'll write an obviously incorrect material into the model file for now. Not the best, but it'll let me continue with what, because that code I'm not sure. Where do I use that code? No, I will use the result of that at some point. But when I get around to that, it'll be an obviously wrong value, and I'll remember what I did and fix it up. Okay. So here. Okay, so here's a problem. Yeah. So remember when I said that I need to change this thing to accept multiple vertex meshes? I said that a moment ago. I think I might have to actually do that now. Because when this thing creates the light map, does it create just one huge light map? Oh, I think it actually does. No, that can't be right. You wouldn't have enough resolution to put an entire level in one light map. So that can't be what it does. Copy in the lights for tracing. And it does this. Converts them all to one big mesh. Looks like that's what it does. That's no good. And then now start writing the output files. All meshes. Where does this come from? I wrote this code a long time ago, so I don't even remember what it does. So it creates a mesh out of every brush. Okay, so what it needs to do is make one model, but that has a different mesh, like a different sub-mesh in the model for every material that it needs to render. Because you're going to have parts of your level that are like, for the sake of easy rendering, like all of these are one material, and so they can all share a light map, for example. And so you just put all of that in one mesh and like pack all the light maps to for this part of the level together. But I don't think I do that. I just... Oof. This is a lot of code. I don't do that. I just pack everything in the level into one model. So I would need to fix this. I don't want to fix this right now. So I'm going to do the same thing I did before. I'm going to take a shortcut, an inadvisable shortcut. I'm going to write to do material. That would probably be way too much work for me to do right now. But it'll need to get done eventually for sure. So what this level compiling code would need to do, sometimes when I code things on stream, it actually helps. I work slower, but like since I have to talk everything out, I think I end up with better designs that way, since I can like reason through everything. Since I'm forced to go slowly and reason through everything instead of just like jumping to a conclusion. That's basically the whole basis of the rubber duck method of programming, right? Where it's like, explain it to this duck. You guys are my duck. So right, what this thing would need to do is group the level somehow into different sections, each section containing its own material. And then write those sections into the model file. And then you have additional choices about like, if you want to split your level up so that this chunk of static geometry, which is a room, needs to show at this time, and that chunk needs to show at that time, and like it streams in and out, then you have an additional level of how you break up the map. I'll have to think about that one more, but we're not going to get into that right now. We're just going to put the material here, and then when we go into the model file, okay, this should all compile now. It will just put the fake material into it right there. Should work fine. Actually, that's a fake. No, we'll leave the fake name there. Okay. Okay. Does this mean I need to take this code and bring it back? Yeah. No. Damn it. Yeah, so the whole reason that I decided to write this code is so that we can have an actual material to work with. And that means what's easier to do so that I have an actual material to work with. Okay, let's do this. Let's just make a crap material and write it out here. I don't think that will take too long. I'm gonna make like a fake material for our level. Gotta close some stuff here. Close this, and close this, close this. I have too many things open. Probably keep that open. Can close this, close that. I don't know, I feel like I want to make some progress tonight. Okay, so in our level, we're going to... So we convert them all to one big mesh. So let's just make a fake material for that one big mesh. Placeholder material for the one big mesh. Hold on 1 second. I'll be back in like less than a minute. 1 second. Mute, damn it. All right. Where were we? Gonna make a little fake material right here. Set PSO light map. Push parameters. All right. First parameter has got to be the diffuse. So T material parameter. Diffuse parameter equals material format. Let's grab the last parameter that we created. That's the diffuse parameter. Diffuse parameter dot set. Set name. Diffuse. Set value. White. So we're gonna use the white texture, which is should be this default white texture right here. Where is it? That guy. As the diffuse texture. Because, you know, we don't have any actual textures yet. So then we'll push another parameter, and then we'll call this one the light map parameter. All right, light map. And so this has to be an actual, like a file, I think. Yeah, this has to be the path to a file. It's probably fine. So I have to like get the light map that this. So I guess I have to turn this back on, which is a shame because it's gonna take forever. Let's see how long it takes. Oh, well, it doesn't compile. But it definitely takes a few seconds and it can be annoying. Oh, I have to, include that header file. Now what? I don't have... All right. Using namespace file formats. Let's just throw this all the way up here. Back parameters. Back parameters. Looks fine to me. No member named back parameters. Oh, there it goes. That was weird. Okay. Well, maybe we could just use the white light map for now too. Yeah, let's not even worry about all that stuff. Let's turn this back off. All right, turn this back off. All right, just for now, we're gonna use white light map. Sorry if I'm interrupting my process, but I'm curious if you can explain your setup. Just came in, so I don't know what you're doing, but I noticed you're using Xcode, but it doesn't seem like you're using it as your main editor. Yes, I really like Sublime. It's nice. I'm not naturally a Mac person, so I haven't really used Mac like my entire life or anything. And Xcode, I don't know. I use Visual Studio a lot more than Xcode. I can't really get used to Xcode. I don't really know my way around it. But I decided I need a debugger better than the command line debugger. So I use Xcode as really just a debugger. And I use Sublime to edit. Sublime I definitely prefer over Visual Studio when I'm on Windows because it just never locks up and Visual Studio locks up all the time. So I typically use Sublime and then like I've hooked it up like at work for example so that I do Control B and it just runs the Visual Studio compile step in the background and then it'll spit out errors here and then you can double click the errors and it shows you the line here in Sublime. So, and this is the same thing here on Mac. I have CMake and CMake produces for this project. CMake produces Sublime project files, and then it's just a matter of it sets it all up for you so you can build here. And like if I screw up, then I double click and then it shows me what line I screwed up in. That's weird. It showed me the wrong line. This line right here. So, I don't know. I've heard Xcode described once as programming using iTunes, and that probably sums up really well why I'm not a big fan of the editing interface. Where was I? Yeah, we're gonna keep that commented out, and okay. So that's a very simple material with one diffuse parameter and one light map parameter, and let's write it out to a file now, and then we can use that file down here in to-do material. So instead of saying to-do material, it can say our file. So let's see here. Actually, I'm going to move this down here to the place where it says start writing the output files because this is an output file. Oh, you know what I'll do? I'll leave this up here. But I'll just take the instance out. So the instance is in this namespace, and so all these variables will go away. So now I can say, okay, I have to say material format instance. Nice long name. And then, so this is the static geometry file. And we'll have to make static geometry material file. All right. Nice error message if that doesn't load. Yep, same stuff. Materials level name dot t material will be the name of the static geometry material file name. Not the most amazing code I've ever written, but what can you do? Let's space this out a little bit right here. All right. So this guy we're going to pass in here. So we pass the name of the material we're going to build right there into the model for the static geometry. And then we should also probably actually write our material into the static geometry. So here's the material instance. Fortunately, I have a function that does exactly this. Format. And here it is. Oh, I'm just going to copy this guy. Okay. And then this guy, good. So that should write the material file. Let's see if it actually does. Well, I guess I gotta fix some compile errors here. Undeclared identifier static geo material file. Static geo material file. Oh, gross. Oh, gross. So the current structure wants me to add the material as part of this list of output files. So that if... Yeah, but I don't really want to do that. Don't really want to... Well, I can do that. It's not so bad. What would that involve? Check files. Check files is over here. So check files is kind of a horrible function that that takes a list of files and checks all of their timestamps to see if any of them need rebuilding. I guess it won't take too long to... This is terrible. But... Format strings. I just have to do this. That should be all I have to do right there. 3 and 3. All right. Should do it. And now I can add this over here. Material. Static geo material file. Full. And then material file. And then material file. And material. I'm gonna get carpal tunnel. And it's crashing again. Wonderful. No, it worked. It didn't crash that time. And now I have material file. Okay. Let's touch the level file here. Test dot level. Wait. Test dot level, yeah. And we'll save that and make Igor run. And it does crash. Okay, so I have a crash somewhere. Will debugging work this time? Oops. Probably not. Everything hates me right now. Yeah, stupid debugger's not working. Ugh. Debugging without a debugger. Do I want to try and do it today? How do I feel? How about this? Ignore that assert. Oh, good. Oh, good. I can just ignore it. Oh, I feel so much better. Okay. I have a debugger back. Why is this? What? It didn't do the... I don't understand anything. Level name. Yeah, so it's trying to append this materials string. So does this append overload? It calls vRealloc. You know what? Oh my goodness. This is terrible. This is terrible. So I have so many strings in this file that this static material FMI and static material file. So there are like two strings that have the same signature. So this is a problem with my This is a problem with my memory allocation library, which keeps this database of all of the allocations that I've done. Yeah, look at that. So this variable's name is so long that it like overflows what the database can use. Oh man. Well, I can just change the name as a workaround for now. That's no big deal. I'll do that. Let's change the name to something shorter. I feel terrible doing this, but something like that, I think. And I'll do it over here just for good measure. All right, that should fix the problem. And there we go. Okay. So touch the file to make sure that it regenerates the, yeah? Did it regenerate things? Let's see if it actually wrote out a material. I don't see a material. Oh, here, wait. Install materials, yeah. Git add install materials. There it is. Test.material. So I'll probably have to go delete that later, but but good. So now we have an example material that we can use. We'll close this, close that, close that. Let's take a look inside that material file. Test.material. Mostly empty. Beautiful. Actually, this looks like, yeah, this looks like the file wasn't truncated properly. None of this stuff should be here. But if I reopen it with UTF-8 encoding, then maybe we can see some of the strings inside. Yeah, so light map, white, diffuse, white, light mapped. So all the information is there. And why didn't it? I don't know. I'm unmapping the file properly. I don't know why it has all that extra space there. That's odd. Oh, maybe. Yeah, see, I gotta do this. Yeah, I gotta do this. I gotta tell the file what size it should be. Here we go. Some material format instance. So the format instance is this size, and I gotta tell the file you should also be that size. So the memory map that I have to the file in memory should be that size, so that writes out the proper. It should have written out nothing, honestly. Test.level. Make Igor run. Now let's look at that. What was it called? Test.tMaterial? No, I still got a bunch of zeros. That didn't fix it. Oh, because I used the wrong stupid. Okay, one more try. Save that, rerun it. Ugh. I need to pay better attention to what I'm doing here. Okay. Now you go to the material. Good, now it's short. Well, that was a narrow miss. Alright. So good, so now we've written all of the data to disk that we need to write in order to have a material system. Only took 2 hours. There's a lot more work to do, of course. There always is. So what's the next step here? Oh, so we go to the resources. And we add a material. Aha, that's nice to do. That's something we can get done tonight. Maybe. I don't know, it's already after 8. So we're gonna add a new handle type for materials. So you have a material handle. Material handles, of course, just a material, like, yeah. So the thing we've been working on. So now we can load a material. Oh, crap. Shouldn't need a draw context to load a material, because material, the actual renderer doesn't know about the material. Materials is an abstraction that sits on top of the renderer, so we shouldn't need a draw context for that. It's just a bunch of data. Destroy material. Well, no, hold on. Let's start with this. Let's start with load material. So now we'll go to, so this is our asynchronous resource handler thing. Pretty sure I covered this. I showed this a lot in some yeah, I did in some previous streams. So load model. Gonna copy this guy. Don't need that anymore. Or that. Okay. So we're gonna make this guy into a material, load material function. Just like that. We don't care about the draw context. So we look up resource by the file name. Don't care about the draw context. If it's valid, we already have this material loaded, so return it. Otherwise, generate an ID for the material. Create a new resource that is that material. That resource will have this material data struct, which I haven't created yet. Create a read task to read the physical resource from the disk. Let's see. And then, so this generates the handle. So it creates the actual handle that you're going to return, then return the handle. Good. So that should fail to compile because this material data thing is unknown. So let's go create that. It'll be kind of like model data, except empty for now. Where do I define model data? Model data. Model data? Oh, oh, model data is out here. That's no good. Do I want material data to be out here too? Let's keep it inside for now. So we'll copy something else. This thing, fragment shader data. Now let's go create model data, or sorry, material data. Material data. Material data. Oh wait. Okay. So we don't have a draw context. We don't have any data at first, do we? Nope. No data at all. All right, so we'll build that. Wow, no linker errors. Oh, of course, because this stuff isn't referred to yet. So there really should be linker errors here saying that like material data is loaded, can't be found, but there's nothing there yet. So nobody references it yet, so it's fine. Okay, create read task. No, that's pretty boring. Create. So wait. So let's just try it. Let's just run that. Wait, should we run that? No, because nobody ever actually tries to load this material. You know what we need to do? So now, when you load a model, it should load the material as well. So let's see. Load model. Create a read task, and then at some point, like, here we go. For every mesh is going to have a model, or sorry, a material, I believe. So this mesh right here, mesh.material. What does that return? Level. T-mesh, perfect. It returns a string view. All right. ETF string view material. So I just want to see what material I get out of here. Make sure it's the same material that I passed in earlier. So we're going to come over here and open up the resources and then say material equal. Search for that line. Set a breakpoint there. Make sure it compiles. Oh wait, I don't want to run Igor anymore. I want to run the editor. Make sure that compiles. Good. And it's going to tell me I haven't referenced this variable, which is fine. I just want to see what it says. Bam. So let's see here. Material. It's empty. What model are we loading? I don't think I have that information anywhere here. Well, that's weird that it's empty. Okay, well, let's try a different one. What? Value vertex data. What? What? Oh. Oh no. Okay, I just have to recompile this model apparently. To do unimplemented means I haven't done the work. Yeah. Crap. I think I could just recompile the model though. If I know what model it is, damn it. Well, okay, there's only like one model in my assets file, so let's see, model. It's this model. And I can recompile it by getting rid of the hash. And recompile it. And so now it should, okay. Hash is back, good. So now it should be recompiled and that should go away. That kind of defeats the point of the versioning in that library, but I'll have to fix that to-do later and then I won't have to do this. Okay, so now that material, so now that that model was rebuilt, this material should say, come on. Give me a little pop-up, give me a little hint thing. Material, where, material, here it is. Good, to-do material. That's that crap that we put in there just for now. Okay, so now I'm gonna hit Control G and hopefully it, yeah, so now it's gonna load, now it's trying to load the level and the level is gonna have an actual material in it, not the to-do material crap that we did. Right, and there it is. Materials, test.material, and then some crap. That crap is fine because notice that the length is 24, so 24 must be the length of everything up to the end of .tMaterial. Okay, good. Good. So, now I have a material file that I can open. So let's do that. Resources. Create wait. Load material. And then I have to resources. Load material. So I have to convert from the VTBF string view to this string view, which is a pain, but whatever. I'll probably make a conversion function if I have to do this too much. All right. So load material, and then from that I should get a material handle. Material handle. And from that material handle, I should load a mesh that has that material instead of these default white and black textures that I had before. So great, so we're getting somewhere. We're removing obsolete code that relied on hard-coded textures before. So let's see here. This should be material handle. Material. So those hard-coded textures are gone now, which is great. Oops. And it's replaced with just the material, which is good. I also have to update this guy to be the material handle. We're getting close. Add mesh here, update him to be the material. This is just a lot of code over and over, material. Okay, So now probably that will give me an error because where else do I use? Okay, draw indexed. Good, 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 good. So now I can specify the material instead of the individual textures into draw indexed. And draw indexed can take as its parameter a material. And then I go to my render. Sorry. The header file. And change this. Material. Good. So now it's going to complain that unknown type name, texture, material. Oh, I'm being silly. Should be material handle. And probably over here too, material handle. All right. So here's the actual kicker is, so whereas before we used this texture and this diffuse and this light map, now we have to get all of this information from the material. So first, let's so we didn't actually even put anything into the material file. Sorry, where was I looking? Material data is still pretty empty. Yeah. So here's what we need to do. We need to add things to the material data right here. And then retrieve those things over here in the renderer. So when I say add things, what I mean is when you load the material from disk, you need to save that data, the disk, the information that you loaded from disk. You need to save it right here in this material data. And that's probably an issue of just like, honestly, you have this format right here and here, like copy, right? So it's probably an issue of just like creating a new object somewhere in memory and copying that data, whoop, right over to here. Another instance that's right here. So it can copy it out of the like as a file mapped into memory. Honestly, probably just keep that file mapped into memory. Is that so bad? Is that so bad? Just keep the file mapped in memory? Could be. And then you like never unmap the file. And so you keep that file mapping right here. It's live the whole time. I don't really think that has any qualitative difference. You may have to like, so you may get the advantage. Oh, here's a question. You have a file mapped into memory and you're reading it, you know, from memory as if it's like some memory allocation that you made. And you're reading it, but you just map it into memory and you leave it there and you forget to actually like go to it later, go to it at the time that you load it. And so the operating system has it all paged out to the hard drive. And then let's say that on the first frame that you want to draw something, then you go and you try and get a material property. Then the operating system's gonna say, whoa, you can't read that stuff because it's paged out to the hard drive. I'm gonna block your process and I'm gonna like load all that stuff from the hard drive, you know, on that first frame, or it could even be like in the middle of your program. And it waits for all that to get paged in from the hard drive before it finally unblocks your process and say, oh, now you can read that stuff, and the process continues. That would be bad. If there is, I'm not sure if I've looked into this, if there's like some kind of function that says, okay, this file is mapped into memory, but seriously, pull it up from the, tell the OS, pull it up from the hard drive. Don't just try and optimize away my, my reads. My file reads. Actually do pull it up from the hard drive. But Like if you want to copy the data into this class, like run this copy function, copy out the format right into your class, then you can make sure, because that data had to be read to copy it over, which is probably a little slower, but is a guarantee that you're going to read that data. So for the time being, that's probably what I'll do, just to be sure. Copy it right there into this material data, so I know I have a something resident in memory that hasn't been swapped out to the hard drive or just hasn't been paged in ever. Hopefully that makes sense. So, so we need to read that data in from the hard drive, fill it out right here, and then when we go to render, access that data, figure out what pipeline. Like right here, we've hard coded. You can see we've hard coded the light mapped PSO. So what we need to do is look up that PSO that we need, and then set all of this stuff according to what is in the material. So wait, not this stuff. This and this can stay, but this stuff needs to be driven by the material. So global UBO, where's that set? Oh, so global UBO is set, yeah, here at like the beginning of the frame. It's set once per frame. It's super efficient. But object UBO, oh, it's set right there. Yeah. So, and these are uniforms. So it'll set these to uniforms no matter what. That part's fine. But then the samplers and the textures need to be set depending on what the light map is. And we already, I set diffuse and I set light map back when I was writing the texture file before. Hello, Majestic Owl Plays. So these need to be set depending on what the material is. How much of that work do I want to do tonight? I feel like I'm pretty close. Let me try to get a little bit of that in play. So we're going to start like this, file formats, and t material and instance. Material instance equals, and we'll get the actual format. T material. Okay. And material data. So hold on. Model. Load material. Create read task. So at some point I actually async read task. Task process. Here we go. Need to make a new load material. There we go. This will say material. All right. Resources, load material, retask. Okay, so this guy needs to be duplicated, load material. And then probably somewhere over here. Here. Load material. Great. I could probably get rid of most of this. Yep, get rid of most of this. And instead of T model, we are loading a T material. Instead of a model instance, we have a material instance. And instead of model data, we have material data. So then material data, and then we have to say, what are we making? Got to go, but I followed. Hello, goodbye. For the record, we're making a material system. Sorry, where was I? So M material instance, we're gonna make a new one, T material instance create. And then we're gonna copy, no, actually copy from this format right here. So I'm also going to have to probably destroy something like destroy model, except destroy material. And give me that material data. And then I'm gonna have to here. Resource pointer M material instance pointer free. All right. So I've created this copy now. I've guaranteed that the whatever is resident in memory because I created this copy. So great. That didn't take too long. Actually, I probably need to come over here. Destroy model. Duplicate this guy. Destroy material. All right. Don't need to defer this. I can just do it right away. I don't think I need this guy because I can do him on the fly. Okay. Aha. Use of undefined. Oh yeah, that's fine. Incomplete type. Did I not include it? I didn't include it. Material. All right, closing in. We're closing in. We're only loaded if our material is loaded, and here's where it's gonna give me the error. Oh, it didn't give me the error because there are still other compiler errors. We'll just comment these out for a moment. And now it's gonna give me the linker error. What? It didn't. What? It didn't give me a linker error. Why not? Material is loaded. What? Material data. That is weird. I never defined this material data stuff. This constructor is not defined. This is loaded is not defined. Model data. Let's see here. Create resource, that's what I need. Create resource. Yes. So I put this here before, but I need to like make it an actual thing. This is super gross and I should probably consolidate this somehow. Type material. There was another place where I did the same thing, wasn't there? There's another, here it is. Unload resource. Destroy material. It's kind of funny, and most of programming is just this rote editing of text. It can get pretty dull sometimes. All right, there we go. Now it's giving us this material data could not be found error, which it should be because I never actually defined it. So I'm gonna stick it down here. Material data. It's still not giving me though undefined symbols for architecture. The first non-inline virtual function has no definition. Okay, so now it's actually complaining about the is loaded business. So I have to write a function that says whether or not my material is loaded, and my material has finished loading if the material instance is not null pointer. Good. We are ready spaghetti. So now the material data is loaded into memory, and I just have to make an accessor for it. Get material data, get material format, I think is all I need actually. File formats T material. And that will take a material handle. And then in my render, I need to say file formats T material format equals get material format, and then pass in my material. So that will get all of the data that I copied over. And that's going to give me some errors because with incomplete return type, oh, I need to wait, actually I need to put it over here. Include file formats dot t material dot h. All right, and good. Here's my undefined symbol. Get material format. Get model data. So we're gonna put that right next to. Where's get model data? Oh, this is the renderer. Here we go. We're gonna put that right next to this. So now we're gonna get the material format. And in order to get that, we get the material data. And then we say data material instance. Oh wait. So first, so we have this assert here, so we know it's always valid. So I'm not even gonna bother checking this data pointer. I'm just assume it's always valid. So then we can get the material instance here. How do we do that? What are we doing? Okay. Get format. Actually, I can just return this. Oh. Yep. All right. Good. So now in my render, I finally have the material data that I need. So let's go to the debugger. Oops. Bring that back. And find the renderer and put a breakpoint here. It's again complaining that I don't ever use this variable that I created, which is fine. I just want to see what it looks like. Oh. I think that means it couldn't find the file name. Real file name to-do material. Great. To-do material is true. It's not a valid file name. Just gonna ignore that one. Ignore that one too. Ignore that one too. Ignore that one too. Ignore that one too. Oh, great. It's not gonna let me go. Okay. Okay, instead of to-do material, what I'm gonna do is I'm gonna put in the path to that material, the light mapped material that we made, because that's actually like it's obviously the wrong material, but at least it will not give me that error. So hold on. So let me do it this way. I have to regenerate the model. I'm gonna do it by, again, removing the hash and letting it rebuild and reassign the hash. Come on, there it is. Okay, good. So it should have rebuilt the model at this point. So we won't get the to do material stuff anymore. Probably get a different problem instead. Oh, so that built. Or that runs. Somehow. Shouldn't I have hit a breakpoint? Oh, no, not yet, because I'm not drawing anything indexed yet. Okay. So, what was I gonna draw? Okay, my light maps. So I'm gonna Control G to go into the level, and bam, there we go. So now it's trying to draw something indexed, and it can't because I have a breakpoint. So let's step through that breakpoint. Of course, I can't get anything out of this material format. I think I can do this. This is why I made this. Wait, eval material format dot print. No, what was it? Is it not eval? It's exec? What is the damn debugger command to it? Is it it's not, I can never remember the name of the debugger command that does this. Always have to Google it. LLDB evaluate. Oh, that's it. Expression. Material format dot print. Oops. Well, that crashed. That's another thing that I'll have to fix. But in any case, the PSO is empty for some reason. There are 2 material parameters, but the PSO is empty. Why would it be empty? So I'm going to go into the resource loader instead. At the point where it copied this thing over. I swear, copy? Here it is. At the point where it copied this thing over, and see if I can get it to spit me the data out. See what the data is straight from the horse's mouth here. So expr model dot print. Yeah, that doesn't have a PSO either. Very odd. So what's the size of the buffer? 192 bytes. .t material. Is this 192 bytes? 12 times... how many bytes do we have across here? 8 times 2, 16. 192 bytes. Let's look at the data. Light mapped. I'm confused. So where did we write out this material? We set the PSO to light mapped. And then we wrote that to memory, to the file. But didn't work somehow. It's not getting this light mapped value. Okay. Well, we got pretty far. I think I might hang it up for the night. It's getting close to my bedtime. There are some bugs, and we're gonna stop a few feet short of the prize, but we made a lot of good progress, I feel like. There's a lot left to be done, of course, but Why would it not? So I'll write some pseudocode for what we have remaining to do. So we have the material format. That's going to have a PSO. Okay. And then we had our lookup function to look up the, where was it? Resources. Look up PSO. So we just look up that PSO right there. And that's going to get us a pipeline state handle. And then we use that one instead of the hard-coded light map PSO. It's going to look something like that. This stuff will be the same. The uniforms, setting the uniforms will be the same. Except for there will be like this I'm going to have to change right here. This, it's going to have to look up these binding indexes according to like whatever pipe PSO that it found. So, but it's going to, you know, loop through all of the, for each parameter in the material, it's going to loop through all of them. And then it's going to set, well, there's some kind of switch going on, on the type of the parameter. Okay. In the case that it is a, you know, a texture, then it'll have to do this number right here. Set the sampler and set the texture based on the parameter value. Something like that. In the case that it's a parameter, now parameter is overloaded, but like a material parameter, then it will have to use another, do another set use uniform buffer for that material parameter. Or actually, probably more like it, there'll be only one, you know, material parameter UBO right there. UBO means uniform buffer object, so we're setting the uniform, we're setting parameters for the buffer. Probably it'll be like buffer parameter equals parameter dot value. So at the end of all of those buffer sets, you update it. Something like this. You update that, and then you use it. Material. Something like that. Then you have all that done, and then you actually draw it. You tell the draw context to draw it. So those are the final steps here, blocking in those steps. So you see, I think hopefully it's pretty clear now how this is a lot more powerful. You have all of the instructions on how to set up the information here in the material, and then you change things in the material, and they should automatically propagate. Two objects can use the same material, so you update the material properties in one place, and they automatically propagate to every object that uses that material, for example. That is one example. Okay, good. Gonna hang it up here. Thank you everybody who was watching. I appreciate it. The questions were great. I appreciate the questions. I hope you guys had a good time, maybe learned something. I learned a few things. Making games is always fun, and sometimes leads you in unexpected places, and we solved some interesting problems tonight. So that was good. Right, signing off. I'm getting hungry again and tired. So thank you again. Oh, next week. Next week, what are we going to do next week? I don't know, man. I don't feel like this was a terribly good topic because I wasn't as solid with it as I thought I was going to be. Try and only make something a topic if I'm like fairly solid with it, and I can I can get through it without too much hemming and hawing. But I felt like, even though I ran into some problems I didn't anticipate, we came up with some pretty good solutions for them. So maybe we'll have another adventurous topic next week. Or maybe something completely different. I don't know. I haven't done the JavaScript compiler in a while, and I have some ideas for how to approach that in a new way. So we might do that. We'll see. It'll be an adventure. I don't really have a clear vision of what I'm gonna do because a lot of things are kind of in flux in this engine right now. So we'll see. I'll definitely announce it on Tuesday. Thank you everybody for coming out. Had a great time.